like we have seen how to write a program in MapReduce, right? So yeah. So here we usually have the data in HDFS. Okay. And then we can write a MapReduce program. Yes, Shiva, tell me.
You have not uploaded yesterday's class videos at Whiteboard yet, right?
I have.
The one for yesterday, because I checked, it wasn't there.
I uploaded them.
Under what? Under week 6?
Yeah.
I have the last one I see is week 5.
1 second. Give me 1 second. Let me log in, and then I can. I'm logging in. Give me a minute, okay?
Yeah, sure.
So what I do is like I use a password manager actually. So I don't use the same password for the different websites. So
Mm.
okay. So need to okay. Okay. For some reason it didn't upload actually. Let me do it right now.
Okay.
So I thought I did it actually. 1 second. Yeah, I'll do it right now.
Right.
So it should say session 6 actually, but like okay. So we are in the same network, right? It should be done in a minute or two. Yeah, it's done.
Okay. All right.
Yeah. Okay. So let's get started with Hive. Okay. So as we have seen, right, like we can process the data using MapReduce. So we can write Java programs as well as non-Java programs. Okay. So we have seen some programs in Java, Python, Ruby, R. Okay, but like as we have seen, right, just for the doing small things, it's a bit verbose. So that's the reason why we can write programs in higher level abstractions like Hive. This was created by Facebook, and similarly another software called Pig, which had been started by Yahoo. Okay. So Hive supports a language called HiveQL, which is very similar to SQL. So it will take Hive as an input and then convert into MapReduce program. Similarly, Pig will take Pig Latin as an input and then convert into MapReduce program. Okay. So I don't need to think about MapReduce and all those things. So like when I think about Hive, so I need to think about tables, select queries, and so on. Okay. So the way Hive is a declarative language, so I specify what I want, but I don't specify how to do it and so on. Okay. So I can say select the average of the marks of the top 3 students from a table. I don't specify how to, right? So just simply I specify what I want. So similarly, Pig Latin is a data flow language. So we usually run different Pig Latin commands. So let's say this is the input. It will go to the first pig Latin command, and then it will go to the second pig Latin command, and so on. Okay, and then we'll get the final output. So basically, the data is flowing from one command to another command. That's the reason why it's called a data flow language. Okay. So today we'll be looking at Hive, and then maybe later on, like we'll be looking at Pig also. Okay. So we already spent some time around MapReduce. So today it's about Hive. So let me try to compare what we already know, the relational database. So this is what we do in a relational database, and this is what we'll do in Hive. So in Hive, in a relational database, right? So we create tables, insert some data, and then we run queries on the table. Okay. But in the case of Hive, again, as I said, right, I will be running queries. So I can't run queries on its own, right? So I need to create a table so that I can run some queries on them. And then we won't be inserting the data into the table. Okay. Because the data is already there in HDFS, right? So we do map the HDFS data to the Hive table which we created earlier. We map it. Okay, so I'll show you how to map it. So then once we map the Hive data to once we map the HDFS data to the Hive table, we run queries on the table as usual. Okay, so the only major difference between Hive and relational databases, instead of inserting some data into the table, we map the HDFS data into the table actually. Okay, so the exact semantics, syntax, and all those things we'll see, but this is the major difference between these two. Okay, so let me put it in a different way. So what do we have? We have the data in HDFS. Okay, so somehow I can do a put, or I can run the scoop import or whatever, and then we have to create a table in Hive. Okay. So what did I say? Like we'll be running the queries on the Hive table. Okay, but there's no associated data in the Hive table. So that's the reason why we need to do a logical mapping between these two. Logical mapping. Okay, so once we do the logical mapping, the next step is we need to run some queries, Hive queries. Okay, so once we run the Hive queries on the table, okay, so the queries will be automatically converted into a MapReduce program. Okay, who will do it? Hive will do it. Okay, and the MapReduce program will be automatically run on the HDFS dataset. Okay, so this is another way of putting it. So if I don't do the step 3, the logical mapping, okay, so how does Hive know on which dataset to run the MapReduce program? Okay, so that's the reason why we need to do the logical mapping between these two. Okay. So this is another way of putting it. So when we ran Uzi, we started the metastore. Okay, so the Hive table definition. Definition means the table name, column type, constraints, and all those things. The definition and the mapping. These two will be started in something called metastore, Hive metastore. Okay, so I'll talk a little bit about Hive metastore later on, but like basically the table definition and the mapping between the table and the data, all these details will be stored in the Hive metastore. Okay, so this is another way of putting out around Hive. Okay, Hive was started, as I said, by Yahoo because they thought, okay, not everyone is comfortable with programming. Okay, so why don't we create an abstraction tool on top of MapReduce, which will make using big data a bit more easier. Okay. Same is the case with Yahoo also. Yahoo started big. And then at some point of time, they donated the code to the Apache Software Foundation, and a lot of other companies have started using Hive and Pig. Okay. So let me point out the sequence of steps. Okay, to use Hive, and then we'll do it one by one. So first step is to start HDFS and MapReduce, because we'll be putting the data in HDFS, and then the Hive query will be converted into MapReduce. So we need to start both of them, and we need to start the Hive metastore also, wherein the table definition and the mapping, all those things will be stored. Okay. Third thing is we need to put some data into HDFS. Whatever way we want to, and then so we have to start the Hive shell. So the way we started the Zookeeper shell, MySQL shell, right? So similarly, we have to start the Hive shell, so wherein we can run the different Hive commands. Hive shell. So within the context of the Hive shell, so we have to create a table. Okay. And then we have to map the table which we have created in step 2 with the data in step 1. Okay, so this is the logical mapping which I was talking about. Okay, so once we have done the mapping, so within the context of the Hive shell, again we have to run queries on the table. Okay, and then finally we have to verify the output of the query. Okay, so these are the sequence of steps to get started with Hive. So we'll see a quick demo of Hive, and then like I'll talk about the intricate details about how to use Hive and so on. Okay, so the syntax and so on. Okay, so let me start the VM, and then we'll do this step by step. Okay, so the first step is to start HDFS and MapReduce. So we have already seen it, so I'll go through it quickly. So let me start it. I'll use the start all command because I need to start both HDFS and MapReduce. So just I'm quickly verifying whether the nodes are up or not. Okay, the MapReduce is up or not. Okay, so we started both HDFS and MapReduce. Okay, so the next step is to start the Hive Metastore. Okay, so here I will open up a new tab. So this is the one related to Hadoop. So when we do the project also, right? So we have like 4 or 5 tabs. So it's better to name them so that like we know which tab to jump to if you want to switch tabs. So first I need to go to the Hive folder. Okay. So what is the command to start the Hive Metastore? So here I have mentioned the commands. Okay, so this is the command. Okay, so here, yeah. Okay, so it is starting the Hive Metastore. So like we don't get to the control back, so open up a new tab. Okay, so this is where I will be running the Hive shell and so on. Okay, so how do I start the Hive shell? So first I need to go to the Hive folder and then say bin Hive. So I'm already in the Hive folder, so I simply say bin Hive. Okay, so here is the Hive prompt. So I can run the different Hive queries here, like the creation of the tables, putting some data, getting some data, like all those things here I can. Okay, so we started the Hive shell. So let me put some data into HDFS. So we can put huge data sets, but like I'll put some small data set actually. Okay. Because if I run a huge program in here, right, so it will take forever. So here I got a weather data set. So let me show you the data set. I can do a cat on the file and then show you the data set, and then I will put the data into Hadoop. Okay, so this is again the weather data set. So the first one is the year, the second one is the temperature, and the third one is the quality. The third column says whether the record is a valid record or an invalid record. Okay, so this is the sample data set, like which I will put it into HDFS. Okay, so here if you see, I'm using the same put command again. Okay, now so if you want to see the list of tables, right, I can say show tables in Hive. So it will automatically connect to the Metastore, and then as I said, the table definitions will be stored in the Metastore. So it will go to the Metastore, fetch the list of tables, and then display it to us. Okay. Now, so I'm already into the Hive shell. Okay, so I need to create a table. Okay, so before that, if the table exists, I can drop the table and then recreate it again. Okay, so here I'm dropping the table because when I say show tables, it tells me that the records table is there. So I'm dropping the table. Okay, now I will recreate the table again. Okay, so here if you see, it's more or less very similar to how we created table in a relational database. Create table records, and then here I need to specify the column name, column type, and any constraints. Okay, and then I say that the data is in a row format. Okay, and the data is separated by tab. If you see the data, right, so when I said cat, so the fields are separated by tab actually. Okay, so here we need to specify the delimiter, how the fields are terminated or delimited. Okay, so this is the syntax. Okay, so here as well that the data is in a row format, because like when I have some data, right, let's say we have some data, like let's say student data. Okay, so this is how the data is stored in a row format. Okay, all the rows stick together, but like we can have the data in a columnar format also. Okay, so this is how the data is in a columnar format. Okay, so there are a few advantages of using the row, few advantages of using the columnar format. So which I will talk about later on. But here, if you see the data, right, the data is in a row format. Okay, so here I say that the data is in a row format and the columns are or the fields are separated by tab actually. Okay, so let's create, like I have already dropped the table. Let me create the table. I'll go to the Hive shell. Okay, create the table again. Okay, so we have created a table, so we don't have any data in it. So if I say select on the table, so it says 0, nothing, right? So because like we, in the case of the relational database, as soon as we create a table, we insert some rows, but here we map the data, but we haven't done the mapping yet. So that's the reason why it says 0 rows. Okay, so what is the next step? So the next step is to map the data to the table, right? So here this is how we do it. Load data in path, and then we specify the data location, and then we specify the table location. So basically it will do the mapping between these two. Okay, so as I said, it's a mapping, right? So it takes hardly a fraction of a second, because like usually in the case of the relational database, let's say when I insert like a million records, it will take a lot of time, but like here it's a logical mapping. Already the data is there, the table is there. We are doing a mapping between these two. Okay, so the syntax is load data, but actually we are not loading any data, but we are doing a mapping. Okay, so I don't like the syntax, but that's the way the syntax is. We have to go with it actually. Okay, so this will do the logical mapping between the data set and the table. Okay, now let's do the map. So if you see, right, like it hardly took a fraction of a second actually, right? So because it's a mapping. Now I should be able to run some queries. How does my data look like? Okay, so I'll try to say select max of the temperature from the table, and then I should get 111 back. Select max of temperature from the records table. So here if you see, it's running a MapReduce program. Okay, so one way is to see it here, or I can go to the MapReduce console, and if I do a refresh, right, so it's in a running job status actually. Okay, so because like behind the scenes, as I said, Hive generates a MapReduce program. So here we see it in a running job status. So because our data set is small, after some time the job will move to the completed job status. Okay, completed job status, and then here if you see, I get the result 111 back. Okay, so and then finally we can verify the result saying whether we got the right output or not. So we ran the queries and then finally we verified 111 is the maximum temperature. Okay, so these are the sequence of steps to get started with Hive actually. There's a lot more to Hive which we will talk about, but to get started with, this is how. Any question? Okay, so depending upon the type of the query we run, like, okay, 1 second. Yes, Ivan.
Does Hive also support table joins, etc., or is
Yeah,
it
you
only
can do
simple
it.
straightforward?
Yeah, definitely. Okay, so let me show you the syntax. It's not as rich as the relational database SQL. Okay, because like relational databases had been there for quite some time, right? So it supports a subset of the relational database syntax. Again, if you relational database, right, there is SQL 2011 and all the different standards, right? So it supports a
Mm-hmm.
subset of it. Like if you go to the Hive page and then the language manual,
Mm-hmm.
so here we got the DDL and the DML commands which it supports actually. Okay, so here is the DDL and the DML commands. So definitely we can do a group by sort, join, filter by using the
Okay.
where clause. Yeah, definitely we can do. We can create cubes and all those things also. Okay, so slowly they're adding more and more features. Okay, they want to make it on par with the relational database, but like it will take some time actually. Yeah. Okay.
Right. Oh,
But yeah, definitely I can create like a sales table, a customer table, and then I can do a join between those two tables. Yeah, that's what we'll do in the proof of concept, right? So like currently we're talking about the different softwares individually, but like when we do the proof of concepts, right? Like we'll see how we can integrate them and then how they work together actually. Okay. So definitely there we will create two tables and then join those two. Yeah, tell me, Siva.
okay, another thing also now, since the mapping is happening to a data in HDFS, so all the primary key constraints, etc., is supposed to be handle the data part itself, is it? Or
So
how does it work?
I don't get you. What is it?
See, now since mapping happens on a data which is already existing in HDFS, so
Hmm.
who's responsible for taking care of all these primary keys or duplicates and all that stuff? I mean, that's
There's no one responsible because like we are just mapping the data, right? So like if someone is
right.
responsible, it will take forever. No one is responsible actually. So if the data is duplicated or like let's say they say the problem with the primary constraints and all those things, right? So it will be there actually. Okay, so when we before we map the data, like we have to clean the data and then we have to make sure that the data is proper. It's our responsibility. Yeah.
Okay, okay. All right.
Okay.
So, yeah.
Because like that's one of the reason why the mapping is faster actually. But like if you take the case of the relational database, like if I insert like a million rows, right? Like it has to validate the data against the constraints against the schema and then it will insert, right? So but here if I do the validations like for each and every row, right? So like we are talking about big data, it will take forever actually. Okay, so we have to do to answer your question. Okay, so there are some tools like Pig, which is basically used for cleaning the data, right? And then once we clean the data, we map it to the table in HDFS. That's the way we do it. Okay, so okay. Okay. So depending upon the type of the query we run, right? Like it will automatically generate a MapReduce program for us. Okay, so here, so I ran the query select max of temperature, right? So uh, select max of temperature from the records table. So depending upon the type of the query we run, right? Like it will automatically generate a map or a map reduce, or it can, if the query is a bit more complex, right? Like it might run multiple map reduce programs also. So here it will run a map reduce program because like reduce because I'm doing an aggregation. Okay, so reduce and then here I'm not interested in all the data. I'm interested in the temperature. Okay, so it has to extract the temperature from the entire record. So okay, so that's a transformation. Okay, so it will use map to extract the data and then it will use the reduce for calculating the max, which is type of aggregation actually. Okay. So if I want to see whether it generates a map or a map reduce or chain of map reduce programs, so what we can do is we can say explain. Okay, so explain will basically show you the map reduce pseudocode which will run behind the scenes. Okay, so here as I simply start from record, it's a simple case of transformation actually. Okay, so let me make it clear. Yeah, you can say temperature. So here I simply say select temperature, so it will run a map program because there's no aggregation. I can say explain. So here if you see there's a map operator tree, but there's no reduce operator tree. Okay, so let's try to make the query a bit more complicated. Like we'll try to introduce some aggregation. Okay, so if I go up, like it will show me a map operator tree. Okay, so here is the map operator tree, and then I have the reduce operator tree. Okay, so as I said, right, like it will automatically generate the map reduce program as required. So let's say like I have two tables, and then I do a join on those two tables. Definitely, it will run two map reduce programs. Okay, so depending upon the type of the query, right? Later on, when we do the POC, right? So we'll, as I said, like we'll have multiple data sets, and then when we do a join, right? Like we'll see that it will generate multiple map reduce programs. Okay. So explain, it doesn't run the program, but it will show the plan, whether it's a map or a map reduce or multiple map reduce programs. Yes, Ivan.
So these map and reduce programs, they are generated on runtime, or are they generated at the mapping time? At which point of time are these programs generated, the map and the reduce?
Okay, yeah, I'll talk about it once again.
Yeah.
So, so here is the big data cluster. Okay, so we have the name node machine, data node machine, and all those things.
Right.
And then let's say this is the gateway. Okay,
Right.
so on the gateway, you need to have the Hive installed. Okay, so
Yes.
I will log into the gateway, and then I will run a Hive query.
Mm-hmm.
Okay, so the Hive query will be passed on to Hive. Hive will convert into a MapReduce program, and the MapReduce program will be submitted to the cluster for execution. Okay,
Okay.
so at the end of the day, the cluster is getting a MapReduce program, so it doesn't need to know whether
Mm.
it's coming from Hive or Pig or anything actually.
Correct.
Okay, same
Correct.
is the case with Pig also. So on the gateway, Pig is installed. So I will log into the gateway, take the Pig Latin, run the Pig Latin. The Pig will take as an input and then convert into MapReduce programs. So again, in
Correct.
this context also, the cluster need not be aware that Pig is submitting it, because at the end of the day, it's getting a MapReduce program. Okay. So it's a client-side library. So to answer your question, whenever I run a Pig Latin command or a Hive command, it
Mm-hmm.
will on the fly it will generate the MapReduce program.
Okay.
So okay, so this is one way of running the MapReduce, sorry, Hive. There are two ways. One is the uh, local mode. So in the case of MapReduce also we saw different modes, right? Like the standalone mode, local mode, pseudo distributed mode. So here also we have the local mode, the MapReduce mode. So this is the default MapReduce mode, so which we saw, and this is the local mode actually. Okay. Um, so uh, in the local mode, right? Like the thing is, like we don't need to start MapReduce actually. Somehow it will mimic MapReduce. Okay, so only HDFS has to be started. Okay, I don't need to start MapReduce. Okay, so I clearly wrote it down, so I'm not writing it again. The good thing about the, the bad thing about this running in the local mode is I don't start MapReduce. Okay, so I can't run distributed processing. Okay, so that's the reason why it can process only small amounts of data. Okay, it can process only small amounts of data. Okay, but the good thing about this is it will run very fast actually. Okay, so small data and fastness. Okay, so basically we use it for unit testing. As in the case of streaming, I talked about unit testing, right? So here also it's used for unit testing, the Hive local mode. Okay, so as I said, right, like it will run in the MapReduce default mode. So how do I run it in the local mode? Okay, so I need to set these two properties. Okay, the job tracker local, and then here I need to specify where it will keep all the temporary data. Okay, so these are the two properties I need to set in the Hive shell. Okay, so then it will automatically start in the or automatically run it in the local mode. Okay, so here as I said, there's no need to start MapReduce. Just to make sure that I'm not using MapReduce, I will stop MapReduce. Okay, so if you run the JPS command, so I don't see anything related to MapReduce. Okay, so uh, now as I said, right, I need to set these two properties to run it in the MapReduce local mode. Okay, so I'll go to the Hive shell and then set these two properties. Okay, so similarly you can set any properties. But, how do I know? Like I need to go through the documentation and then figure out what all properties I need to set to run it in the local mode. So when I ran it in the regular mode, let me see the time it took. Yeah, so when I fetched the maximum of temperature in the MapReduce mode, I got 111 back, and then it took 22 seconds, let's say. Okay, so it took 22 seconds. Okay, now let me run the same query in the local mode. I set the same the properties. Now I run it in the local mode, the same query. Okay, so the same query, max of temperature from the records table. Let's see. Okay, now if you see again, we got the 111 back, but it ran in like 5 seconds. Okay, so we have cut down the time from 22 seconds to 5 seconds. So because as I said, right, like we are not running in the MapReduce mode, so we don't need to use MapReduce. So everything will run on the same machine. So small data sets, but as we have seen, it runs faster actually. Okay, so this way we can do the iterative development and all those things. Yes, Siva.
Okay, now you've set these properties, right? So is there a way to see the complete configuration of Hive? Number one question. And now if you want to start an MR mode, how do you unset these properties?
You have to exit and then start the Hive shell again, then you will be running in the
Okay.
default mode. What's
So
your
you
other
have to
question?
exit. Okay. Where do you see all these properties that you have set in Hive? Is there a config file or something,
Something like a config file. I think you can do a set and then see all the config.
something like, is there some show properties or something like that?
So you can say set and then so it will show you all the properties set actually.
Uh, okay.
Okay, set and
So this
then anything which you have to terminate it with a semicolon, right? So set semicolon to show you all the properties.
okay, so we can also find this particular thing, and the one that you just said just now.
Yes. Yeah. I
Okay,
need to
fine.
scroll up, scroll down. You try it out later. Definitely you should be able to see it actually. Okay.
Fine. Okay.
Yeah. So basically, uh, we run in the local mode, as I said, right? Like the small amounts of data fast. So basically, it's used for unit testing of the code. Okay. So this is how we do it. Yeah. Okay. So you asked me how do I undo it, right? So one way or the only way is to exit. Okay, because like any properties which I said, right, like those will be only for this session and then it will be gone. Okay, now let me start MapReduce bank. Okay, now let me start Hive in the regular mode. Okay, now like when I run a query, right, it will run against MapReduce. Okay, so it will run in the regular MapReduce mode. Okay, So now if I want to run the in the local mode, right, I need to set the two properties again. Every time, like it's difficult to set the properties, right? Let's say I need to set some 10 properties, I need to set them again and again, right? So it's a bit difficult. So that's the reason why what we can do is we can set all the properties in a file called hive.rc. Okay, so I can put some commands in the hive.rc file. So this file gets executed whenever we start the Hive shell. When Hive shell is started. Okay. So similarly, in the case of the Linux suite, so there's a command file called bash.rc, and this gets executed whenever we start the terminal, Linux terminal. So all these set commands and other commands which we were going to talk about in Hive, right? Like you can put all those things in the .hive.rc file, and whenever we start the Hive shell, it will be automatically getting executed. So we don't need to set all those properties again. So same is the case with the Linux also. In the bash.rc file, right? Like I set a few properties saying that export $Hadoop home is equal to some folder. Okay, so that's the reason why whenever you say cd $Hadoop home, it will automatically take you to this particular folder. Otherwise, how does it know? Right? So these are called environment variables. Okay, so okay, you can set it in the hive.rc file. So there are different ways of running Hive. Okay, so we saw how to run from a shell. Okay, but like let's say I want to do it in a more of an automated fashion. So I can put all the DDL and the DML commands in this particular file. Okay, and then pass it on to the Hive command. Okay, so earlier we have seen how to run it in an interactive fashion. This is more of an automatic fashion. Okay, so I don't need to run one by one. And the other way to run this particular file is like I can create a workflow as we have seen earlier, and within the workflow I can invoke a Hive script with the DDL and the DML commands actually, or through Uzi also. Okay, I can do the same thing with Uzi also. Okay, so second thing is like I can use the -e option. So instead of specifying a file, I can simply specify the DDL or the DML command. So this is another way of running Hive. Okay, so these are the few ways. You can try it out later. Okay, specify the -f and then specify the file, or specify the -e and then you can specify the query also. Either way. Okay, so you can try it out. Like if it doesn't work out, let me know. I can help you. Okay, so it will be like a small exercise. Okay, so let me talk about something called local. Okay, so when we did the mapping, right? Like where did we have the data? We have the data in HDFS. Okay, so it we have done the mapping between the table and the file. Okay, so now, right, like here, when we do the mapping, right, like if I specify the keyword local, it expects the data in the local file system or the Linux file system. Okay, so what it will do is it will automatically copy the data to HDFS. We don't need to. Okay, so here, if I don't use the keyword local, it expects the data in HDFS. So I need to put the data. But here, when I use a keyword local, which is an optional thing, it expects the data in the Linux file system, so I don't need to use the put command. It will automatically put the data into HDFS. So just we are avoiding this single put step actually, nothing more than that. Okay, so let's try it. Local is an optional thing, so we can't specify it actually. So let me drop the table and then create the table again. Now, if I say select star on the records table, okay, there's no data, so I'm not using the put command, so I use the local. Okay, so it will automatically copy the data. Okay, and now if I say select star from records, we should see the data. Okay, so that's how the local option works. So similarly, let me talk about overwrite. So in the case of Hive, uh, so in the case of Hive, right, like what we can do is like, let's say we have a student table, okay, and then I map it to student1.txt. So let's say some new students come into the school, and then it means that we have some new data, right? So I can create another file in HDFS, and then I can map it to the existing table. Okay, so whenever new data comes, I can map it to the existing table. So whenever I run a query on the table, okay, so it will run the MapReduce program on all the underlying data sets associated with that particular table. So I can map one table with multiple files actually. Okay, so it can work the other way also. Okay, so let's say I have a student file. Okay, so I can map it to a table called student, and then I can map it to a table called student1. Okay, so maybe I use different column names here, I use different column names here, and so on. Okay, so it supports one table to many files, many tables to one file actually. Okay. So in the same context, let me talk about overwrite. Okay, so overwrite. So when we use the word overwrite, it will do two things. Okay, overwrite. It will delete all the existing mappings, and then it will create the new mappings. Okay. So delete all the existing mapping means it's very similar to truncating. So like when in the case of the relational database, if I say truncate, right, like it will delete all the existing data, right? So similarly here also it will delete all the existing mappings and then it will create a new mapping actually. That's the significance of overwrite. Okay. So first let me explain you the code and then we'll see the same thing in practice actually. Okay. So here we have two files, sample.txt and sample copy.txt. Both of them we are putting into HDFS, and then I'm creating a table called records, and then I'm mapping the sample.txt to the records table. Okay, so now as I said, right, like I could do multiple mappings. So this time I'm mapping the same records table to the sample copy.txt. Sample copy.txt. Okay, so here if you see, like I'm using the keyword override. Okay, so what it will do, like it will delete the existing mapping. So it will delete this particular mapping. Now only the table will be mapped to the sample copy.txt. Now if I run a query on the table, it will be run only on this particular table, sorry, data set. Okay, so now when I say select count or something, right, so it will show me all the data from the sample copy.txt. Okay, not on the sample.txt. Okay, so let's see this in practice. And then if you have any questions, we can ask me. So this is the case of with overwrite. So we had 5 records. So again, I need to drop the records table and then recreate it again. Okay. So I'm putting the sample.txt and the sample copy.txt, both of them to HDFS using the put command. Okay. So let me quickly verify the data. Sample.txt has 5 records and the sample copy.txt has 5 records. Okay. Now let me, I dropped the table, so let me create it again. I need to go to the Hive shell. Okay, now I need to the mapping. Okay, so I'll run these two commands. Okay, now it is mapped to only the sample copy. So now if I say select star from records, it will show me only the 5 records. Okay, so basically overwrite, it's very similar to truncate. It will delete all the existing mappings as truncate deletes all the records actually. Okay, so now let's try without overwrite. So when I drop a table, right, like automatically the data will be deleted. So I need to put the data back into HDFS again. So let me verify the data is there. Okay. Now this time I won't use the overwrite option. Okay. So here I'm mapping the records table to the sample.txt. Records table to the sample.txt, and then I'm mapping it to the sample copy. Okay, so this has 5 records. So this has 5 records. Here, if you say I'm not using the overwrite option, so the table will be mapped to both these tables, and when I do a count, right, I should get 10 actually. Okay, so let's try that out, and then we will move on to something else. Yeah. Okay, so it's mapped to both these files. So if I say select star from records, so if you see, I got 10 rows actually. So when I say select star from records, right, like it's not running any MapReduce program, right? Like we are getting the results immediately. Why do you think so? So as I said, right, like whenever we run something in Hive, we do get it runs a MapReduce program, right? So here it's not running any MapReduce program. We do get the results immediately. Why do you think? Just type it out. Not running mode. Like we came out of the local mode, right? Like I did an exit and then started the Hive shell again, right? Why do you think so? Not because of the data in the memory, because say like when I ran the query, right? So what are we doing? Like I'm not doing any aggregation, right? And there's no reduce. So I'm not fetching any particular record. So I say select star, right? Star means get everything. So there's no transformation also. Okay. So there's no transformation, there's no aggregation. So what am I doing? I'm doing nothing actually, right? So that's the reason why it's not running a MapReduce program. So as I said, right, like depending upon the type of the query, it will decide what to run, right? No aggregation, no transformation. So why? So basically when I say select star from records, I say simply display all the data associated with the records table. Okay, so what it will do is it will get all the data from HDFS and then display me. Why do we need a MapReduce program to display me the content of a file? Right, so that's the reason actually. So the data is not in the memory actually. So where is the data? The data is there in the HDFS. We are talking about big data, right? Like if I keep everything in the memory, it would be sufficient actually. Okay, the data is there in the file system HDFS. Okay, so anyway, that's the reason. So uh, here, right, like uh, okay, so talked about override. So here, right, the output of the query is just a few records. But let's say the output of the query, right, like it's like a million records. So I don't want all the million records to be displayed to the console or the output. I want to store it somewhere. Okay. So there's some command called insert override. Okay. So insert override and then the directory. We have to specify where the output should go to. Okay, and then specify the query itself. Now the output of the query will be redirected to this particular folder in HDFS. It won't be displayed to the console. Okay, so that we can later analyze it out, right? Like as I said, right, like when we have millions of rows, right, what will I do if I display them? I need to store them somewhere. Okay. Now if you say we haven't got anything in the output, like basically we said store it in HDFS in a particular folder. So here it says 2 rows loaded into this particular folder. Okay, so let's go to the folder and then check it out. Okay, so here is the output, the year and the max temperature. Okay, so that's the query we ran. So this time, right, the query is a bit more complicated. Like basically we want to find out the maximum temperature for each of the year actually, not for the entire year. So for each of the year, that's the reason why we do a group by. Okay, and we say year and the max of the temperature for each group actually. Okay, so I don't want to discuss on the query too much because it's a very exact, not very much like, but it's exact the same as the SQL query which we run. Okay, so here I'm doing a group by year because I want to find out the maximum temperature for each year, and then here I'm filtering the data. Okay, because I need to filter out the invalid records. Here when the temperature is 9999, it's invalid record. Similarly, when the quality is 01459, it's a valid record. So I need to simply filter the invalid data. Okay, so yes, Ivan.
In the query or something, can you put a separator out here? Because there was no separate in the output file, correct? So can you put a comma or a tab as a separator out here?
Yeah, definitely. I need to find the syntax of it, but yeah, definitely we can specify the delimiter actually. Yeah,
Yeah.
yeah. We can specify
Yes.
the delimiter. Yeah.
Okay.
So yeah. So like so here what did we do? The output went to a file. So the output can go to a table also. Okay. So here the so I say select star from the records table, and then instead of saying insert override directory, I say insert override table and then specify the target table. So output of the table will go to another table. Okay, so table to table. So here before that I need to create the target table. So here I'm creating the target table and then moving the data from one table to another table. So this way, let's say I have a records table. Okay, so it will have both valid data plus invalid data. Okay, now I can move the data from this particular table to the records target table. Okay, so when I run the query, right, like I will filter out the data so that it will have only the valid data. Okay, so now my query on the records target table will be much simpler because I don't need to worry about the invalid records. Similarly, I can do some aggregations and then move the data to the target table. So then the query on the target table, it becomes simpler actually. Okay, so yeah. So you can try it out. Like all these commands are tested out, so try it out. Okay, so I have already shown you insert override directory. You can try the other insert override table also. Okay. Any question till now? Okay. Okay. So let me talk about Hive. In Hive, right? Like there's a concept called UDFs actually. Okay. So so we have seen min, max, all those things, right? So these are the inbuilt functions, and we can create our own functions. Okay. So we can create a function like calculate tax, calculate the sales commission, and all those things. We can create a function in Java, and then I can integrate it with my query. Okay. So this way, right? Like any complex things which are not well suited for a SQL, right? So I can do it in Java and then integrate it with the SQL query. Let's say I want to do some complex natural language processing, right? So I can do that actually. Okay. So, so like we'll take a quick break of 5 minutes. It's 12:03, 12:10 we'll meet. Okay, 5-6 minutes break, and then like I'll start with the UDFs then. Okay, at 12:10 we'll meet there. Okay, thank you. Siva, are you there? Hello? Okay. So yeah, I see you. So yeah, let's get started with UDF. So these are the sequence of steps, and then we'll see the same thing in practice actually. Okay. So first step is to uh, develop the UDF. We have to write the code, right? So develop the UDF in Eclipse. Okay. And then we have to create a jar file. We have to bundle it up, and then like we have to register the jar file, because like there might be like hundreds of jar files in the system, right? So we have to tell Hive what is the jar file of our interest. So we have to register the jar file. Okay. Then uh, we need to create something like an alias actually. I'll talk about what it is. Like we have to create an alias. We'll see. Once we create an alias, then we can use the UDF in our query. In our query. Okay. So these are the steps for creating a UDF. Okay. So let's see them one by one. The first step is to develop the UDF in Eclipse. Okay, so here I have created a project called Hive UDF. Okay, so which has the related code for the UDF. Okay, so if you click on properties, build Java build path. Okay, so here we need to specify two things actually. One is the Hadoop core and the Hive jar file. These are the two dependencies for compiling the code. Okay, so let's look at the UDF code. So this is a simple UDF code, but like we can do much more complicated things also. So let me tidy it up a little bit. Okay, so okay, so here like whenever we create a UDF, right? So we have to extend the base UDF class. So this base UDF class, it's a part of the Hive package actually. Okay, so that whenever we create a mapper, we extend the base mapper, right? So here also we have to extend the base UDF class, and then we have to implement a method called evaluate. Okay, so the like whenever we use a UDF in a query, the evaluate method will be called automatically. Okay, so this takes a Hadoop data type as an input, and then it returns a Hadoop data type as an output. It can be int writable, float writable, double writable, anything. But like in this case, it is taking a text which is a string as an input and output also. Okay, then we need to do some processing. So here basically I'm doing the validation whether the input is a null or not. So if it is not null, then first step is I need to convert the uh, input data into a Java data type string. Okay, so then I'm simply converting into a lowercase. Okay, so this will return me a lowercase Java string, and then I need to convert into a Hadoop data type back. Okay, and then I need to return it. Okay, so simply I'm creating converting a string into lowercase string, but like simply I can replace the logic here and then do some complex tax calculation or some natural language processing or whatever I want to. Simply I can replace this function with much more complicated things actually. Okay, so basically we are offloading the some of the functionality from the SQL query to the Java. Okay, so this is how And next we need to create a jar file. So how we have created in a MapReduce, right? It's same. Export as a jar file. Next, sorry, select the project which you want to export, and then here you need to specify the jar file path. So I will simply say 1 second. So I will use the exact okay, the path. So the name is the same, so that I don't need to modify the command. Okay, so putting it on the desktop and then say finish. Okay, now if I go to the desktop, I should see the files there, the jar file there. Okay, so if I crack open it, I should see the UDF compiled classes. Okay, so this is the class, compiled class. Okay, so next we have to register the UDF. For registering the UDF, there's a command called add jar. Basically, this will put it in the Hive class path. We are telling that we are interested in this particular jar file. Okay, so here this is the command add jar and then specify the path. Okay, so we don't need to run, if you don't want to run it again and again, so we can put it in the Hive RC file. Okay, so now it's not there in the Hive RC, so I need to run it manually. Okay, now I can, as I said, right, I need to create an alias. So if I want to use this UDF, right, so I simply need to specify the entire package name as well as the class name. Okay, so we need to, instead of that, like, we can create an alias, or we, okay, so to create an alias, the syntax is create temporary function called myLower, and then I map it to the UDF class. Okay, so I don't need to specify the entire thing. I can use a alias called myLower. Okay, so again, right, like this command also you can put it in the Hive RC file so that you don't need to run it again and again. Okay, so okay, let me create an alias or a temporary function. Now I can use the UDF in the SQL query. For that I need to create a table, put some data and so on. So here I'm creating a table called students. Okay, and then map it to the students data. So before that I think I need to drop the table. Okay, I created the table back again. Now, so here if you see, I'm using the keyword local, so I don't need to put the data into HDFS. Now, if I say select star from the students table. Okay, so if you see, some of the names are in the uppercase, some of the names are in the lowercase. Okay, so let me use the UDF and then I will convert all of them into lowercase. So this is the one which we created an alias of the name from students table. Okay, now if you see, once I start using the UDF, like I see all the names in the lowercase. Okay. So as I said, right, like we can use much more complicated UDFs, but simply replace the logic here. But simply I'm converting a string into a lowercase string. Yes, Siva.
So these functions are temporary functions, right? I mean, so if you close the shell, it goes off, is it?
That's the reason why I
Or
said,
does
right,
it
like
stay?
you can, yeah, it goes away, but like that's the reason why you can add them to the Hive RC file, so that like whenever you
Okay,
start this, right, like they have, it will create the temporary function again.
all right. So you can't register them permanently with Hive, as you know, there's a
No,
min
that's what I
max
said,
or
right? Like,
something. You
yeah, one way to register is to add it to the Hive RC file. So there's a
okay? That's
permanent
the
way,
only way.
right?
Hmm. All right.
So, yeah, whenever we start the Hive shell, right, the Hive RC gets executed, so I don't need to register it again and again, right? So that's one way. Okay. So the way the Hive supports UDFs, right? Like UDFs, right? So they do apply across single row, like lower, upper, calculate tax, and all those things. So they do apply across a single row. Okay. So Hive also supports something called user-defined aggregation functions, so which apply across multiple rows. Okay, like min, max, and so on. Okay, so it's a bit complicated. Let's see if we get some time, we'll talk about it. Okay, but it supports both of them. Aggregate, you can create your own user-defined aggregate functions also in Hive. Okay. So, okay. So let me talk about partitions and then we'll park for the day. Okay, so for the next 15-20 minutes, we'll talk about partitions actually. Partitions. Shiva, like, just wanted to plan my activities. Like, how is it? Like, you want to have the full day tomorrow, or like, are you okay with like 10 to 1 or 10 to 2, or what do you want to?
Yeah, like I think Saturday and Sunday, let's focus on on long days if it's possible. Try to catch up as much as possible, and the
Okay.
others is yeah.
Okay, so you want to have a full day then tomorrow.
Yeah, yeah.
Okay. So can we cover the partitions tomorrow then? So we this is what we had. Okay, till how is it? Yeah, you want to cover partitions today?
Can we at least look at an example of a UDAF also? Do you have anything on UDAF with you? Maybe we
I
can
need
just look
to.
at that.
I don't have it. Like I need to prepare it actually.
Okay, then fine. Did you get a chance to look at the scoop
No, I
issue
got
that I
it.
sent?
I got it yesterday evening, right? So today morning I got into something else. As I said, right? Like I have these action items. Definitely, I will wrap them up actually. Okay.
Not a problem. So yeah, then we can start tomorrow. Not an issue at all.
So okay. So these are the
Yeah.
things which we talked today. If you have any questions, ask me. So we'll tomorrow
I,
plan from 10 to 4, like with breaks here and there. Then okay, that's the plan for tomorrow day after.
yeah, 8 o'clock to yeah. That's fine. That's perfectly fine.
10, right? My time.
Your time 10 o'clock. Yes. Can we make it a bit a little bit later? Can we start at say same as today 11 o'clock, 11 to 4 or something? Is that okay with you?
Okay, no problem. No problem. Yeah.
Yeah.
So you
Fine.
have got something else tomorrow?
I know it's like 7:30 is like too early in the morning. It's our weekend, so
So
we
like
tend to
we want to
work.
make it like a one-time thing, or like the all the sessions from tomorrow onwards.
No, tomorrow we can. I mean, if we can on Saturdays and Sundays, we can start from
No, it's not like
11.
a one-time thing, right? Like it's forever. You want to like 11 to
Yeah, yeah.
4,
We
right?
can keep it from 11. Yeah, we can
Okay,
keep it from 11.
so it's not for one-time thing tomorrow. It's a
Yeah,
continuous.
yeah, yeah.
Okay, no problem.
Okay.
No, so that
Thanks,
like
man.
just I want to mark my calendar so that like I can plan something else, or I can also wake up late, right? So that's the
Yeah.
reason why I'm asking you. Right?
Sounds
So
good. Sounds good.
forever. Hmm?
Yep. Yep.
So yeah, tomorrow 11 o'clock then. Okay.
Yes.
Hmm?
Yeah. Okay.
Okay then.
Thank you.
UDF, I need to work some examples.
Mm-hmm.
Definitely, as I said, right, like there are a couple of things on my plate. That's the reason why I keep an open list so that like both of us are aware like what is there, what is not there. So definitely before I
Sure.
wind up, so I'll make sure that I close all of them actually. Okay.
Sounds good, man.
Hmm?
Sounds good. Thank you.
Yeah. Yeah. Yeah.
Okay.
Thank you.
Take
Okay.
care. Bye.
Bye.